Thanks for coming to this talk, talking about Gradle and JavaScript. So my name is Luke Daley, my details up there, engineer at Gradleware. I work on Gradle itself, training and consulting, etc. In a former life I developed web applications not too long ago and was involved quite heavily in JavaScript around that time. But if you're involved in JavaScript at any point, you would know that things are moving very rapidly. So I wouldn't call myself somebody up to date with the latest and greatest in JavaScript, but know a bit about it from an automation and tooling point of view. So about latest, whatever greatest testing framework got released yesterday, don't ask me about it, I don't know, but tooling side of things, let's talk about it. I guarantee there was a new one released yesterday. The Gradle and JavaScript. Well, JavaScript. Why are we talking about JavaScript at a build conference? It's of growing relevance to everybody. A couple of years ago, there were many people who didn't have to touch JavaScript, could ignore that it existed. Very few of us developing anything near the web, or even on the back end, just for headless integration apps. JavaScript is becoming a bigger part of our lives. So it's just growing in reach and growing in relevance. If we look at JavaScript historically, it's a pretty poor story in terms of tooling and build automation. It really wasn't necessary. Most of the JavaScript we did was about creating JavaScript files and putting them in our web application and job done. We didn't really need tooling and automation and these kinds of things. If you contrast that to the JVM, in the Java space in particular, we have a very strong history of being concerned about tooling and build automation, to the point where we have these religious wars about build tools. So there's a bit of a difference in culture around this as well. There are no build time dependency management conventions in the JavaScript space. Nothing that I would say has conquered this space the way that Ivy, but probably more so Maven, effectively has. It gave us a real standardized dependency management framework to distribute work in terms of the libraries, to break these pieces up, and to reuse them. So that's been around for quite a while, and we kind of take it for granted in the JVM space that this is the way things work. It's really quite different in the JavaScript space, though there are quite a few moves by different organizations to do something in this area. And no very well-established structural and process conventions. If you check out a Java project from GitHub, and you see that it's a Maven project, you've got a pretty good idea about the way it works. Similarly for a Gradle project. You can check it out, have a look. You expect things to be in a certain way. We have structural conventions. The good thing about that is that we can kind of apply what we learned about one project to another, etc. This doesn't quite exist in the JavaScript space yet. Like everything, these things are developing and things are coming along, but it is more of a bit of a Wild West. And that has some implications for automation. So what do we mean when we say JavaScript automation? Well, a few different things. Bundling. So taking raw JavaScript assets at development time, and we have to do some processing, combine those things together to get them to production for performance reasons. So minification is another aspect of that. It's really a form of compilation where we strip out unnecessary characters from the JavaScript to reduce the file size. Testing. Testing is a type of automation, of course. And we're now testing JavaScript as a necessity because we have so much logic wrapped up in our JavaScript. When it was just a few scripts here and there, this wasn't really something that was thought about. So testing JavaScript, and actually requires more automation to do it properly than it does in the Java space. Code analysis, JS lint, etc. Transpiling. This is probably becoming less popular, but about 12 to 24 months ago, it was very popular to use languages that compiled into JavaScript. So just adding more stages to the pipeline. In the Java space, it's pretty straightforward. We have source files, we turn them into class files, we jar them up. Most of the time, job done. Talk about automating the build of JavaScript. We can have 4 or 5 or 6 processing stages along the way. We can go from Coffeescript to JavaScript, then bundle it, then minify it, test it, etc. That's a much more complicated pipeline. And at the end of the day, what this is all about is that we've moved from writing JavaScript scripts to creating libraries. To a different kind of software structure, modules, reuse, concerned about namespace clashing, Just a whole bunch of different concerns because the scale has increased. I don't think that this is really a huge one yet, reuse, but will become more and more so. In-house teams will try and be developing their own JavaScript libraries that they want to use across multiple projects. Majority of cases, a lot of JavaScript code that isn't things like jQuery and these kind of high-level libraries are locked up in specific projects. We haven't quite gotten to the point where we create really useful, there's not the proliferation of reusable libraries in the JavaScript space like there is in the Java space in terms of scale. There's lots of JavaScript libraries out there. If you go and look at them, there's a few big ones and lots of small, tiny ones. Nothing really in the middle, which is where most in-house reuse occurs, somewhere between those two. All right, so when you think Gradle, a lot of people think Java. That's about automation for the Java platform. But really, Gradle is a capable general automation engine or platform. So we can use it to automate on any other platform as well. And if you don't have the out-of-the-box support for doing task XYZ, as we'll see, Gradle is a toolkit that gives you the lower-level bits and pieces you need to automate these things yourself. One of the common things you'll hear said about Gradle is it lacks the amount of plugins that the Maven ecosystem has. That's absolutely true, but it's also not as big a problem as what you would think. Because if you're working with Maven tooling and you need to fulfill a new requirement, your options to do that are quite limited if somebody else hasn't written a plugin to do that for you. Gradle degrades much more gracefully and we can just scratch our own itches without too much ceremony. The first thing we're going to look at is how can we use Gradle to publish JavaScript to JVM-based sharing infrastructure. So we're going to use Gradle to publish some JavaScript up to what is effectively our Artifactory or Nexus repository. So, turns out to be quite simple. I have a simple JavaScript file. Content doesn't particularly matter. It does some stuff. And let's say this is a more sophisticated library, and I may have done some processing here. It may have originally been a bunch of files that I've compressed into one JavaScript file. But what we're looking at here is I just want to upload that to my Nexus or Artifactory, which is our common infrastructure for sharing development assets. So in Gradle, I apply the base plugin, which gives me some functionality that I need for uploading. We typically don't apply this directly ourselves because we're used to using the Java plugin, which brings this in for us. But we're doing some uploading without the Java plugin, so we drag that in. We're treating our Artifactory repository as a Maven repository, so we apply the Java Maven plugin. Specify the naming coordinates just like for a Java project. Then we're going to create a zip of all of our JavaScript. You've got a zip task. Use the Gradle DSL to specify that this is something we're going to publish. What we're saying here is that there is a container of things to publish called archives. That's actually coming from the base plugin. It's creating that for us. This is a container of things that I can publish called archives. What we want to publish is the zip task. Sorry, the zip up here. And that's all I need to actually publish that. So instead of publishing to a Nexus or Artifactory repository here, that would be a HTTP URL, possibly with a username and password. We're just using a file URL for the sake of the demonstration. Now let's say that I don't want to actually publish the zip. So we publish zips all the time. I just want to publish the JavaScript file. Source main book.js.
Oh, you missed the JS.
Yeah. Oh, yeah,
Source JS
sorry.
name. Source JS name.
So I can actually publish raw JavaScript files as well. If I have a look in my repository that I created, there's my JavaScript file. Instead of publishing a jar, I just publish my raw JavaScript file. I didn't specify, let me specify a version so get rid of that unspecified. It looks a bit weird. My repo directory is inside build. I just want to wipe that out.
So you can use source sets here as well with dependencies between them and things like that?
No, not really, because it doesn't make any sense in JavaScript. What are compile time dependencies? What are runtime dependencies? It's a whole different dependency management model.
Right.
So all that stuff doesn't really work.
So there's a different dependency manager.
It doesn't really exist.
Use that within the includes and stuff like that.
Effectively, what I can do in Gradle is, let's say, consumer, right? So we're going to, in another project, pull in that JavaScript file. Just say new file, build.gradle, and I have repositories. Where do I get my JavaScript from? Well, I get it from the Maven repository at, which this would normally be my, what did I call it, 01 publishing / build repo. This would normally be my nexus. And I say dependencies, actually, create a new bucket of dependencies. Don't have to use compile, runtime, etc. because they don't exist in this domain. And this is going to depend on my.org, my.org book 1.0 JavaScript file. We don't usually have to specify the @ because we're dealing with jars, which is the default. But we're saying we want the JavaScript file. So now I have that, and I want to say, well, task copy JS is of type copy all my JavaScript dependencies into source main web app JS.
What about things like minified and...
We'll get there.
Oh, good. Okay, thanks.
JS. Really? I got the path wrong, I guess. Publishing.
You need a slash.
Yeah.
Oh yeah, thank you.
There we go.
Right.
Yeah.
So now I have downloaded my JavaScript for me. So, point is here that we can use Gradle's publishing and dependency management mechanisms to push and pull down JavaScript that we want to share. Why might you want to do that? Let's say this is a JavaScript file that another team is using, and they're publishing nightly snapshots. When I build my build in the morning, I want to get that new version and incorporate it into my build. That's typically what we use dependency management for.
So if I'm using a stack like Backbone and Require.js or something like that, I could create a Backbone configuration and a Require.js configuration and set up where I want them to go.
If you needed to control where they went, if you just said dump them all in the JS directory, I could just add more dependencies here.
Right.
Backbone, blah, 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 blah.
Yeah,
but the problem is that they're now just a bag that I can throw.
Yeah, we want to separate them out.
Mm.
So that's how I would have to set up a different
Yes.
configuration.
I'll talk a bit more about that at the end, and what that kind of means. So the thing there was that we can use Gradle's publishing and downloading mechanism to share JavaScript. And it also means that you could manually, by hand, if you say that I don't want developers to check in Backbone or jQuery into their projects, but those things aren't available in a Maven repository out in the wild, you could hand upload them to your Nexus or Artifactory and fetch them this way. So there is no Maven Central for JavaScript, and again, that's something I'll talk about.
So
Are you coming up with one?
We'll talk about it.
So why would you use that mechanism as opposed to, say, just checking them into source control?
What happens when your development team, are you talking about like jQuery and things like that?
No, just like your own.
So what happens when they develop a new snapshot? You email the team producing that JavaScript file, emails you the new copy and you check it in?
They would just check it into source control and we would check it out.
It's a different project. It's in a different project.
In a different project, yeah.
Unless
You
have
lose-
a project
yeah.
like ours where it's everything's in one big. Yeah.
Right.
You don't want duplication of that code all over the place. That's why you want to use like an
And,
artifact.
and you lose the
Right.
information as well. You lose the authoritative source of where did that thing come from.
Yeah.
That's the interesting thing. So dependency management is about information about dependencies, fundamentally. Okay, so we saw one aspect that we can use Gradle for already. Now, to talk about JavaScript on the JVM, we have to talk about Rhino. Rhino is an embeddable JavaScript runtime that is implemented in Java. So it runs in the JVM. This allows me to run JavaScript code on the JVM. It was driven by Mozilla. Under pretty active development, it's slowed a little bit, but it keeps up with the latest in the evolution of the JavaScript standard. So it's completely spec compliant, runs all JavaScript that conforms to the spec, which not all browsers do either, so you can run into issues there. But anyway, it's stable, reliable, been around a long time, is the basis for quite a few different technologies. And if you're running JavaScript code in the JVM, at the moment, it's really the only game in town. Why would you want to run JavaScript code in the JVM? Well, a lot of JavaScript tooling is implemented in JavaScript. The code for statically analyzing JavaScript code is implemented in JavaScript. So if we can run that on the JVM, then we can run our dependency analysis, static analysis in our Gradle build. So we have the ability to run JavaScript in a Java environment, and Gradle has the ability to manage Java-based processes. There's a built-in task type called Java Exec, which provides a specific configuration DSL and some functionality around launching Java processes. So what we're doing here is we're integrating JS hint into our build. JS hint is implemented in JavaScript. So all we need is an environment to run JavaScript. We don't really want to start a browser just to run JS hint. That's pretty heavyweight. Just to get a JavaScript runtime. So all we need is Rhino on the JVM. So Java exec to launch a Java process. We need Rhino on the class path of this process. Rhino gives us this entry point, which is essentially a JavaScript shell. And it takes essentially the first argument we pass to this function is the name of what's called the driver file. So it's some kind of entry point here, and JSHint.js is arranged in such a way where it can accept the rest of the arguments. So what we're saying is run JSHint.js on the Rhino JVM and pass some JS as the argument to JSHint. And this last line here is making the point that here we're using the task type. If we wanted to do this kind of thing as part of a larger task, we could use the project.javaExec method. It does exactly the same thing, but it's implemented as a method, not as a task.
Can that second argument be a file tree, etc.?
No, because these essentially end up being command line arguments. So we need to list the
we would have
files.
to, like in the last one, we would have to create custom tasks or a file tree to go through.
You could loop through that file tree and add arguments for each item in the file tree, certainly. But we'll see when we get to, we'll see where this starts to break down. But let's do this first. All right. So, as a build master, somebody says that they want to have JS hint. You have a Gradle build for your web app. You're starting to add some JavaScript, and the front-end developers are saying they would like JS hint to run as part of the Jenkins build. Reasonable requirement. So what you can do is that we're saying, okay, we're going to need some dependencies here. Specifically, we need Rhino. We need somewhere a bucket to put that Rhino dependency in. We create a Rhino configuration. this is the version of Rhino we want to use, and we wire it up just like we had in that slide. So here we have jshint.js, and I could get this. This is the implementation of jshint.js that I got from the internet. We could go and check this into our Nexus and use that mechanism we just saw to pull it down. And here's my actual application code. Doesn't do too much, but that's besides the point. So this is what we want to run jshint on. So given this, I have a completely portable implementation or mechanism for running jshint. It's complaining it doesn't like that JavaScript. So let's just make that pass. Now, it failed because when it found the JavaScript it didn't like, jshint threw an exception. That caused the process to exit with a non-zero exit code. Gradle says that's a failure. Right. So one of the things about this is it's not too bad. We get information on the console about what happened. If the analysis failed, we get a failed task. It fails the build. But our communication mechanism is kind of limited, right? All we get is whatever jshint puts to the output and the return code. Works for most cases, but we'll see what we can do if we need something richer. So, I mean, pretty straightforward. JavaScript tooling on the JVM with Gradle. Completely portable. I don't need to go and install Node and a bunch of platform-specific binaries. So, very portable. And I mentioned that at the start, in the lack of, if you don't find a jshint plugin out on the internet, 4 or 5 lines, get your own going. It's pretty straightforward. You don't need plugins from other people to do a lot of this stuff. It helps, of course, but if you can't find one, we have options for doing it ourselves. So when we're talking about JavaScript files in general, it's often more complicated than just a single file, and we can use Gradle's built-in file abstractions to help us here. File tree is probably the most useful to talk about. So Gradle has this mechanism for talking about some kind of hierarchy or collection of files. So we might, in our build, in our automation, want to talk about all of the JavaScript files in source main.js. And this is kind of the mechanism that we can do that. We can create a Gradle file tree that says all of the files in source main.js that match this pattern, this ant style pattern. Similarly, doing the same thing with Coffeescript here. So when you're doing this kind of JavaScript-y automation on Gradle, having a good knowledge of file tree and file collection help a lot. You can feed these into tasks and use this to generally wire the configuration of the files you're working with. It also allows us to build the processing chain. So if you're in my talk previously, I was talking about source tasks and task dependency inference, these kinds of concepts. This is really what we're talking about here, but we're using it to implement a kind of processing chain. So we have a Coffeescript compile task here, which says that it compiles the Coffeescript source, which is defined as this. We could then create another file tree, which is the combination of our raw JavaScript source, because we have some raw JavaScript as well as Coffeescript, and the compiled Coffeescript is what that is saying. The files from the Coffeescript task as a file tree. So we now have a merged file tree that talks about the JavaScript with its hierarchy and the Coffeescript with its hierarchy. And I can feed this to later processing downstream, and the task dependencies happen for me. Now in this case I've got 2 tasks, not so much of a big deal. My processing chain gets complex. This can be a real good thing for maintainability, because I can just create these kind of variables and encoded them in them as their dependency information. I don't have to maintain an explicit list of task dependencies across the whole build. You really see this when things get more complex.
So that as file tree returns something that's dynamically evaluated each time.
Yeah, it's a lazy specification. Yeah. So here's that kind of idea in action. We have some JavaScript, some Coffeescript. Coffeescript JavaScript, and we're basically just going to pretend at this point we're compiling Coffeescript. We will show Coffeescript compilation in a second, but substitute this in for a Coffeescript compiler. It's doing essentially the same thing. And if I run zip here, the idea is that Gradle just works out what other tasks do I need to run before I can deal with all the JavaScript. Right? Compile Coffeescript happened first because I said that zip works on all the JavaScript, and this is the definition of all the JavaScript. Now, that means that the definition of what all the JavaScript is can grow and get more complex over time. I don't have to change this guy. So if things happen further upstream in the processing chain, the configuration downstream, I don't need to change them each time it changes up here.
As a best practice, do you typically take those defs of those sorts of global things and pull them out into a separate script plugin or something like that?
Or create my own extension, or if you're in my previous talk, yeah, exactly. So Gradle's dependency inference and rich model here can just make a complex processing chain more maintainable over time and easier to understand. It turns out to be a good environment for doing that kind of thing. All right, using ant tasks. Renee is doing a talk, I think later this afternoon, or it might be tomorrow, on integrating Gradle with other tools. Yep.
So that's the implicit part depends on. Would you envision in the future something like a include if produced, like if the task or a must run after kind of thing? Since I don't think that logically exists right now.
I don't quite understand the question, sorry.
Suppose there was a in between there, minify Coffeescript, but you would have to explicitly say that you wanted to do that as one of the tasks. And you had that in the all JS as something that was added, but only really use it if it was produced.
Sure. So you can, the file collection could refer to a collection of files that may exist, directory that may be empty or it may have files in it. But I mean, it's a bit of a weird case, saying that this processing might happen or it might not, and not kind of reflecting that in the model.
Agree, and it's not a super common thing.
You could do that basically because you can have a file collection could be empty. So all JS could be defined as this plus this plus this plus this. One of those things you're plussing with might be empty, it might not. If it's empty, then there is flexibility in this because this data structure, while it just when I ask it for all the files, gives me the files, the definition can be much more complex.
Right, but I guess now if you did files on that minified form, it would force it to get included. It would force to run that.
Sure. Yeah. Which is part of the model. That's what you've asked for. We might take that offline. I don't think we're quite getting it. All right, using ant tasks, we can package anything as an ant task. So point here is that it's very easy, and there is some JavaScript tooling out there implemented as ant tasks. The point of this part of the talk is we're going through some of the built-in things in Gradle that we can use for JavaScript tooling. We'll see some JavaScript specific stuff coming up. In this case, we're using Google's Closure compiler, which is a JavaScript compression tool. So, Closure compiler provides an ant interface. So we can grab it in, use this ant XML and compress our JavaScript. So if I want to do a similar kind of thing, and say, well, yeah, okay, well I could get the closure jar and I could re-engineer this and find out what code this is integrating with, do my own API, or I could just use Gradle's ant integration to use exactly the same interface to do JavaScript compression. So I'm just reusing that exact same ant functionality, but driving it from Gradle. So let me just get this across a bit. As you can see, it's a bit wordy, but what we do, create a new dependency configuration, say we want the JavaScript closure compiler jar, create a new task called compress. We need to define, it's not built into Ant, so we need to define the task definition and say, what's the class that backs that task def and where does it come from? We can just use Gradle configuration.
Because you're using Ant sources there, does it know you get the incremental compile and incremental?
No, you don't, no. But Renee might go through this, but you can take Ant things like this and make them incremental. So what I could do, instead I just kind of did a cheat way here and just did a default task and put my logic straight in here, which is exactly what I said not to do in my other talk. So I could make a class compress JS extends default task or source task, have inputs files in here, have a Gradle like DSL, Gradle configuration, and my task action method is this. Right,
Oh,
so I can wrap Ant code quite easily in all the Gradle machinery, but it's just be a little bit too much for this particular demo.
Yeah.
So yes, it just becomes an engine at this point. I can do all the Gradle-like things with this kind of approach. So I have two different files, JavaScript files. I want to compress them together. Google Closure is a really, really good JavaScript compression library. You can do symbol minification, all kinds of things to really compress things down. In this case, we have such simple JavaScript files, we're really just using it for concatenation. In this case, I say, well, JS compress, compile task, etc. ants.js compress, compression level simple. We want verbose output from there, and we want to compress everything to output.js, and we're going to compress file1.js and file2.js in this directory. If you ask me, this is a pretty poor interface, passing a space-separated list of files. That's the way Closure works. And the Closure Ant task, anyway. So now if I run Gradle compress, it doesn't like it. I'm in the wrong directory. It downloaded that library, ran Ant, and now I have my compressed file, so the output of that Closure compiler. So there are many other examples of things out there that are implemented as Ant tasks for JavaScript tooling, very easy to use in a Gradle build. Phantom.js, very important thing to know about if you're doing JavaScript-based automation, because it's the most realistic headless browser environment. By headless means it has no display, there's no GUI. You can't see the web page it's at. It's WebKit based, so based on the same engine that the current versions of Chrome and Safari are based on. So it's not a approximation of a browser. It's a real world-class browser engine. There have been attempts at doing this kind of thing before. If you come across HTML units, it was kind of the first attempt to do a Java-based browser. That was a complete Java-based implementation that behaved completely differently to every other browser in the world. So it was a great technology. It's pretty amazing to try and implement a browser in Java and as one open source project. Don't get me wrong, I have a lot of respect for it. But it was never a real simulation for a real browser. So with Phantom.js, it's a real engine. It's the same kind of engine that Safari and Chrome are using. It's fast, because those engines are fast. It's actually faster than Safari and Chrome because it doesn't have to do any painting to the screen. So it just gets a bit of optimization there. Being headless, it's quite controllable. We can script it and we can automate it. Though it is implemented, not sure what language, but you do have native binaries. So you do have a Mac version, Linux version, Windows version. So if you're using it for automation, you need to be sensitive to that, so that if you're provisioning Phantom.js in your Gradle build, look at the environment, make sure you get the Mac one, etc. So once we have Phantom.js available, in this situation we're just going to assume that the user has Phantom.js installed on their machine. And we used the Java exec task previously to launch Rhino, a Java-based process, this kind of thing. Now we're launching Phantom.js, which isn't Java-based. We're just going to use the exec task. So we can launch Phantom and do what we want with it. So how does that work? So I do have Phantom JS installed in my machine, and I get a shell here, or I can script it, tell it to go to this website, that website, etc. So given that I have Phantom installed, this is all I really need to do to drive it. I have a file here. What I'm going to do is tell Phantom to go to google.com and save the output. But this is not like using a HTTP request to hit google.com. You get something very small back then. A lot of google.com is driven by JavaScript. What we're going to get back here is the actual browser state. So after the DOM has been rendered, all the JavaScript has added a bunch of elements. So we're getting the browser's interpretation of google.com. It's very important when we come to testing. So simple exec task, run Phantom JS, use this driver script. We use JavaScript to drive Phantom. It has an API, and we're saying effectively all this means go to whatever the first argument is we pass to Phantom, and after the page is loaded, grab the HTML, pump it to standard out. So I can have whatever I wanted to in here, sophisticated stuff, interacting with different sites, etc. At this point, we're just using Phantom as an evaluation engine, essentially. Run some JavaScript in a HTML-like environment, like a browser does. So if I run this, the rest of this is just creating files and creating spaces to write things. Gradle. Actually, first thing, let's just that's what I get back from google.com. Based not much more than a bunch of JavaScript, essentially. Right, so if I just do a HTTP request without a browser, that's what google.com is returning. And we'll see that that's not what we get with Phantom. So if I run Gradle space Phantom. So we launched Phantom, told Phantom to go to google.com, execute all the JavaScript, render the entire environment, send back what did the page look like after that. And this is what we get. Which, believe it or not, is actually different. If I open that, that's what I get. So I hope that's clear. There's a difference here. This is not just about making HTTP requests. Phantom is a real browser. Can run JavaScript, all that kind of stuff. And we can automate it. That's the thing. Has an API. We can tell it to go to certain pages, grab content out, do that kind of thing. And that becomes interesting when we get to JavaScript unit testing. Because JavaScript unit testing is rarely actually unit testing, and you need a browser environment to run it. You need a DOM. You need a place to be able to jam elements into the page and do all that kind of stuff. So something like Rhino is not enough, because Rhino is nothing about the DOM, knows nothing about that whole thing. It's just executing plain JavaScript. We need something that where jQuery can run, etc. And Rhino is a good fit. Sorry, Phantom JS is a good fit for this. So we're going to look at Jasmine. There's lots and lots of JavaScript unit testing tools out there. As I said, there's probably a new one came out yesterday. So Jasmine is a BDD style tool with given, when, then, etc. Kind of narrative style. Originally developed by Pivotal Labs before it became Pivotal Labs. Needs to run in a browser. You can't run Jasmine just with Rhino. You need a browser-like environment, because the feedback it gives you is via writing to the DOM. You interact with it via HTML effectively. But Phantom JS isn't portable. We do have native binaries. Wouldn't it be nice if we could run our JavaScript unit tests just the JVM, so we don't have any portability concerns? Well, it turns out we kind of can. Env.js is a pure JavaScript implementation of the DOM. And it's pretty close. This is basically how most of jQuery is tested using this. It's actually developed by John Resig as well. So it's a JavaScript implementation of a DOM, which means that we combine this with Rhino. We have a completely portable based environment for executing JavaScript unit tests. It does work with Rhino. There's a specific version for that. And it's a reliable approximation of a real browser. It's not a real browser, but if we're talking about JavaScript unit testing, we're not talking about testing browser features. We're unit testing JavaScript code. And this is more than enough of an approximation for JavaScript unit testing. Yeah?
Why wouldn't you use Phantom JS for that?
It's not as easily automatable in the fact that you need to pre-provision Phantom JS, install it on different locations, etc. There are some other reasons. It'll become a little bit clearer as we get there. So let's have a look. So we have Rhino again. And we just have a little bit more going on here in that we have a few different sets of source. We're creating a poor man's DSL here, creating a JavaScript extension to the DSL, which is actually just a map that we create elements on demand for. So what this means, creates the main JavaScript source, which is just all the files in source.js main. This is a poor man's source sets. So just a map with a creation on demand mechanism, and we're just using that mechanism to create these guys. Don't worry too much about that, if that's not clear. I kind of went through that in my last talk. We're here to talk about JavaScript. I need to prepare the test suite. I have my JavaScript code here, which is just pure unit test. I have a JavaScript class, which is a book. Nothing about DOM in here. I'm not talking about divs and tables, etc. This is just pure JavaScript. And I have a Jasmine test for it. So when I create a book like this, I expect that title to be set. That's what a Jasmine JavaScript test looks like. Now my harness is I need a bunch of HTML machinery in order to run this guy. So this is a kind of skeleton where I pull in all the Jasmine libraries, and I actually have, it's a template. This is effectively Groovy code inside this HTML file. We'll see how this is driven in a second. So for each of the source files, include it. Then for each of the tests, include it here. This is kind of like setting up our class path, kind of. Then we just bootstrap Jasmine, and one of the things we can do is tell Jasmine to give us our results in a JUnit XML file. Why do we want to do that? Well, Jenkins, all those guys, they understand this file in terms of test output. So I can get nice big red warnings on the CI server when my JavaScript breaks. So, come back to here. This task here, prepare tests, is just about gathering all that stuff together. So de-templatizing that guy. So, from the main JavaScript source, copy into the source directory. For all the tests, copy into test. And here, from all the harness files, what we're doing now is building up a list of all of our sources and tests. Right? Because we've got it as a file tree, so we can talk about the hierarchy. Now we just want it as a flat list, so we're doing it this way. We also need them as relative paths, so we're just using the Gradle file API to do this. Then we're saying that if we're copying the spec runner HTML file, which is our template, then the source variable is actually all of the paths to the source files, etc. So just setting up the variables to inject into our template so that this correctly gets expanded. Right. I need to do this kind of bootstrapping. I could do it by hand. I could hard code, say that okay, there's book.js, book.test.js, etc. in here. That's what most of the other tools can kind of do. But we've got Gradle, we've got an automation platform, we can automate the generation of the test harness. So once I've got that, back down here, we're launching Rhino, Java Exec. It depends on prepared tests, so before we can run the tests, we get them together. We have to create this directory where Jasmine's going to write its XML files because it doesn't do it for us. It's just kind of a bug in Jasmine that it expects that directory to exist. No problem, Gradle's flexible, do first, create that directory. When we run the tests, we want to run them in this directory, which is where we gathered together the test harness. We need Rhino in the class path. We're using the Rhino shell, and we're using the env.js bootstrap, which is similar in to what we just saw with Phantom.js. We had to tell Phantom.js where to go. Now we're telling env.js running on Rhino to go to this file, spec.rhino.html. Yes?
What about the Groovy part of that?
It's basically here, in the template.
Oh, the expand.
Yeah,
Okay.
expand here. This is saying that if the file we're copying is spec.rhino.html, then it's actually a template and these are the variables inside. That's what that was saying.
And
That's just built-in Gradle functionality when copying files. You can just say this is a Groovy template.
And it just runs the Groovy and replaces it.
Yeah.
Nice.
how does it know that it's a Groovy template?
Because we said so, basically. If this is the file that we're copying, so each file says do this as you're copying each file.
Okay.
If this is the file we're copying, then it's a template and expand that stuff out.
Expand means Groovy template.
Yeah, it basically means this file is a template and these are the variables, source and tests. Yeah. We could do whatever other kind of things we wanted to do in there. So, at the end of the day, we have building of our harness, then a task using Rhino and env.js, which gives us Gradle test. There goes Jasmine. I can't remember if I made this incremental. No, I didn't. I could make this incremental, but I just didn't for some reason for this example. So, I was running Jasmine. This is standard output being pumped out from Jasmine as it's running our tests. Running on Rhino on the JVM with env.js. Very portable, very easy for CI servers to deal with. I didn't need to pre-install any software, kind of thing. And what we get is our JUnit XML file from Jasmine. And we also get what Jasmine did to the DOM at the end of the test run. This looks a bit better if we make it fail. So we expect this to be that. Well, definitely not that. If I wrote it back, I was in the wrong place. I was in where we built the harness. That's not going to work. This is the right file. 0 of 1 passed. Now, Jasmine env.js doesn't have return code, so we have a bit of a problem here that the didn't pick up that the test failed. So what we could do, and we'll see an example of this later, is that after this is run, go and have a look at those JUnit XML files and work out if it failed or not. So we have to do a little bit of extra stuff here. And now this looks like this. This is what Jasmine did to the page. If we had run these in our browser, this is what we would have seen. But env.js saved that out for us, so we can go and look at this. So let's say, so quite a portable, convenient environment. The Gradle Js Plugin is developed by Eric Wendelin. It's a kind of mix of a whole different few different bits of functionality, such as using Clojure compiler, so it supports out of the box combining files, minifying with closure compiler, gzip, just kind of more convenient version of that, JS hints, JS doc, whole bunch of kind of standard JavaScript tools in one collection JavaScript plugin here. So this is the Gradle Js plugin on GitHub. So let's have a quick. So this is kind of like the main JavaScript plugin in the Gradle space right now, and it's really just an integration point for some of these things that we've been doing so far. Eric's working pretty actively on that.
2 hours ago.
Yeah, doesn't surprise me. I just killed my slides, damn it. So I definitely recommend if you're doing this kind of thing, have a look at that, because under active development, if you ask for something, it's a good chance that it will be added. It's kind of like the central place. All right.
By the way, the slides that we have are not matching what you have.
Oh, really?
Since you have really old in here.
Okay, I'll get them updated. As soon as this is over, I'll upload the new ones. I should be able to click the refresh button and then get them, so I apologize for that.
Only a couple of them extra ways.
Okay.
And then where do we get a copy of the code?
It should be on the, sorry, this one is not on the USB stick. I will upload it to the site. You'll be able to get it from the GradleSummit.com site,
Okay.
where you log in, yeah. I was just a little bit late with this one, didn't get it in on time. Okay, Gradle Js Plugin. So to use it, we pull it in, it's on Maven Central, we apply JS. It has a kind of source set implementation, and we can just use its out-of-the-box tasks for combining, minifying, gzip, etc.
Nice.
It's incremental, it does inference, does all the right kind of things. Which is more, there are a couple of different JavaScript plugins out there for Gradle. Most of them don't do all the things that plugins should, whereas this one is quite good. So if you just need to do some of these simple things in your build, combine some things, minify, it's a great place to start. Check it out. In the interest of time, I'm not going to demo it. It's just, we'll do the same things that previous ones did. We've got some other things to look at. So the Gradle Js plugin, if you Google for that, you'll get the top hit, which is Eric's plugin. All right, Grunt Js. Grunt Js is a native JavaScript task runner. You could call it a JavaScript build system, but I wouldn't quite agree. So there's no JS based. You need Node installed to run it. Has support for lots and lots of plugins and tools. It's very, very popular in the JavaScript space, and it's a very good and capable tool. So this is kind of the thing that's going on in JavaScript automation right now. It's quite a decent community. It's moving very fast. Support for lots of plugins. Most interestingly, I think, for a lot of people, is that it has built-in support for automatically processing changes to files. We're talking about how with JavaScript you have these complex pipelines with lots and lots of processing steps. What you really want is that when something changes upstream, it just trickles down. And Grunt has a kind of implementation of that. So Grunt Js and Gradle. Well, Grunt Js is very JavaScript focused. It doesn't do anything about backend technologies, unless your backend is Node.js, of course. But if you're integrating with something else, like a Java web app or something like that, and you have a kind of more complex architecture that you're trying to automate as one, Grunt Js can't really do that. So what we can do is we can actually put Grunt Js and Gradle together. Drive the whole process from Gradle, but use Grunt Js for what it does well. So, what I have here is a project. It is a Java-based web app. Essentially, we have a Java backend and a JavaScript frontend. We also have a Grunt file in here. So this is the definition of the Grunt build written in Coffeescript. And all we're going to be using it for now is compiling some Coffeescript. We're going to use Grunt to compile our Coffeescript for us. We're also going to set it up so that it will automatically watch for changes in our Coffeescript and compile it for us. So anything in here that matches, we're using Grunt's Coffeescript plugin to compile it. And we also have to explicitly state that, okay, when these files change, run this task. So it sets that up for us. We have that. We need some other machinery in here, like a Grunt, it's a build system unto itself, as I said, so I don't want to cover all the details. I just need to kick this off. I need to install all Grunt's dependencies in my project, is what I just did then, npm install. So now I have in the project a bunch of different node dependencies and things going on here. You typically wouldn't check this in. This would be like checking in your Maven local directory or something like that. So in our Grunt file, we effectively declared all the things that we need to run the build, and I just ran npm install, which is node package manager, to get that up and running. So a few things we would need to do, but now I actually have a valid Grunt environment, and in my build I've written a few very, very simple Gradle tasks to drive Grunt for me. So I have Grunt task, which is just a default task. Its implementation is effectively just to call out to Grunt and drive it. So I specify as part of the configuration what arguments do I want to pass to Grunt. Grunt has a different name on different operating systems, some extra stuff, and I call it, let it do its thing. Now if I'm talking about, let's just see that in action. So I have source, main, Coffeescript, some Coffeescript code here. If I was to run, let's have a look here. This is a Java project. I have a process resources, depends on Grunt Coffee. Grunt Coffee task just says, okay, I want to run this Grunt task. These are the args to pass to Grunt. Gradle Grunt Coffee. Right. So we can ignore this. I just need to update this demo for my Gradle version. Ran Grunt Coffee. This is the output from Grunt coming through here. Gradle took its output and sent it to the console here. So we've compiled the Coffeescript and we created this guy. Now, just for this, I'm going to use an application framework called Ratpack. Here's my Coffeescript compiled to JavaScript that it created. So Ratpack is my backend server technology, which is Java-based, actually Groovy in this case. So I have a JavaScript-heavy front end and a Java backend. I want to develop that together. And also I'm using Sass. So Sass is a CSS type framework, or it's a CSS language, sorry. So it's more advanced than CSS and it compiles into CSS. It's what all the cool kids are using these days. Sass is useful by itself. It's even more useful when you use it with something called Compass. Compass is a Sass framework. It gives you structure to all your CSS effectively. It's a very, very cool thing. I'm using the Compass plugin that is out there for use. I'm pulling it in from bin tray up here. So what we're going to see, let's just see it in action and then we'll dissect it. Gradle run. The Compass plugin is going and installing Compass for us. Compass is actually implemented in Ruby. What's happening behind the scenes here is that it's installing a bunch of Ruby gems and started up Ruby via JRuby. So at this point, what we have, our application is running. Scroll past it, did we? Where did it go? We should have seen a URL pop up here somewhere. Okay, it's up and running. Not sure where the URL went. So we have our Java-based application running. Grunt JS running in the background, sitting and watching for changes to our Coffeescript.
Right above your hand, actually, 3 lines up. Info.
Yes, there it is. Localhost 5050. So the Ratpack app has started. So Java-based process is running. Compass is running via Ruby, run in JRuby, sitting and watching for changes to our Sass files. And we have Grunt JS sitting and watching for changes to our Coffeescript files. So this is what the application looks like at the moment. Just the front page, built by Gradle, Ratpack, Compass, Grunt, Coffeescript, etc. So this little line at the bottom is actually added by our Coffeescript. browsers don't understand Coffeescript, so we have to compile it down to JavaScript before it gets used. This is what it looks like compiled to JavaScript. Now in this environment, I've got my application running, my watch is happening. Save this guy. Boom. Grunt was running in the background, saw the change, recompiled, away I go. So I can just change my JavaScript. Everything's fine. Coffeescript. Now, I can also do the same for my Sass. So here's my definition of my styles. Coming in here, editing. Actually, no, I don't like those logos. What does that look like? Oh, that's not a comment. Logos are gone. So Compass running in the background, saw the change to my Sass files, recompiled. So all these things are outputting into my web app directory, effectively. So it's a pretty tight development workflow. And I'm using Ratpack, which also supports runtime reloading on the server. It's just Groovy code. So I can just change my server code as well without a restart.
It's almost like programming Ruby.
Now. So the Compass plugin, the Gradle Compass plugin, is not doing anything too special. It's just using some JRuby to fork a JRuby process. We can see our Grunt integration didn't take too much work at all. Quick shell over launching the Grunt process and managing it. When we're watching, we need to keep the process up and running, so we're just launching that in a separate thread. I do this slightly differently in real code, but this is the simplest demonstration of this idea. So very easy to implement those things. And now I can do all the really cool things that Grunt can do. It has support for a whole bunch of things. I can put it in here, or even better, I can let my front end guys loose on this. And as being responsible for the entire build, I can just integrate it with Gradle, combine it with all the back-end stuff that I need to do. Pretty cool stuff. So in this case, Gradle is kind of acting like a spider over all these other technologies and integrating them. So if you're interested in more of the details and some more examples of integrating different things, definitely check out Renee's talk. So I think the future is, in a big way for Gradle and JavaScript, is just some richer and more out-of-the-box support for dealing with Grunt JS. It's something I think you can expect that we're still talking about. All right, what are we doing for time? What time is the session scheduled to finish?
12:15, I think.
Cool. All right. So we are building out, we have been over the last year, in core support for JavaScript. It's currently not documented, it's still incubating, so it's subject to change. And our initial goal is to provide foundational infrastructure for other JavaScript tools. So the kind of pieces that you need at the low level to effectively use JavaScript-based tooling. So far we've been forking processes and using Exec and Java Exec, etc. We can do something nicer. And over the time, looking at expanding to dependency management and hopefully getting the kind of experience that we get with Java projects, where we just get a lot out of the box. All right, define some inbuilt repository definitions. For some of the tooling that we support out of the box, we need some JavaScript, so we've uploaded that to a JavaScript repo on our public repository. There's not much there, just exactly what we need to drive Coffeescript compilation, etc. And we also provide a dependency notation for pulling from Google's public JavaScript repository. There's nothing like a Maven or Ivy repository. We can use the flexibility of Gradle to actually pull dependencies from there. Deep Rhino JS integration, more so than what we did with Java Exec. We'll see why that's important. Inbuilt support for Coffeescript compilation, JS hint, which really shows off the Rhino JS integration, and MJS. So the repositories, if you apply the Java plugin, you get some more DSL in the repositories block. So javascript.gradle, which is our public repository, and Google APIs if you want to get jQuery here. So if I want to get jQuery in my project, because it's hosted on the Google API repository, I can just do this and then refer to it with this kind of notation. Just like we did at the start when we were consuming. Rhino integration. Provide support for running Rhino code in forked JVMs, but that's kind of an implementation detail, with arbitrary versions of Rhino. It's not tied to a particular version of Rhino. JavaScript is moving quickly and we expect new things to be added. It allows access to the JavaScript runtime. We're not running it in such a way where Rhino is a black box and we can only communicate via standard streams. We can get access to all the JavaScript data structures. There's a bridge between the Java and JavaScript world, and we can reach in and look at things. We'll see an example of this. So really getting at richer data types. We have access to the full JavaScript model for tooling. Provides much deeper integration. So we're building this so that people can build really great JavaScript tooling on Gradle. So let's have a look at the Coffeescript support. So it's actually there in Gradle 1.1. We've been working on it for a little while. Apply the Coffeescript base plugin at the box. I need to get Coffeescript from somewhere. So let's just comment this out for a second. I need to get Coffeescript from somewhere, so we can get it. It's in a Maven style repository up in our public repository. I add a task of type Coffeescript compile. It's a source task, so it has a very Gradle-like API for specifying what is to be compiled. And I specified the directory to compile that to. So in here, I have a tree of Coffeescript. And I want to compile all those guys in one go. Gradle, compile Coffeescript. And behind the scenes, we're launching up Rhino, loading up the Coffeescript compiler, which is implemented in JavaScript, driving it, passing it the names of each of those files, and gets compiled and matches the same hierarchy. That may not seem like a big deal, but all the existing Coffeescript compilation solutions don't preserve hierarchy when compiling trees. The reason being is that the Coffeescript compiler can only compile one file at a time. So you have to do some extra management around this. That also means that if you're using Rhino and the way we did before with Java Exec to compile Coffeescript, that means one process per file. Doing it this way with the built-in support is one process. We launch Coffeescript once and drive the compiler multiple times. So you can only do that by deeply integrating with Rhino. That's the idea here.
This is in 1.6?
Yes, it was actually in 1.1. So Coffeescript compilation. So it just it's pretty out of the box. I mean, and what I was also going to show here is that by default we get Coffeescript 1.3.1, which was the version that was latest when we put this in. If we want to use a different version of Coffeescript, I can configure the JavaScript extension. It has a Coffeescript extension. I can say, well, actually the Coffeescript JS is this other version. So you don't have to use the built-in version of Coffeescript that the plugin is using. JS hints. We saw JS hint being used with Rhino. But let's have a look at what we use it with the new integration, what's possible. So now we're using the JS hints plugin. We get out of the box. We have to bring in Rhino. We don't actually need to do this, but in this case we're saying we don't want to use the version of Rhino that Gradle defaults to. So we want to use a different version of Rhino because a new version has come out. So we're actually not using this. So we could just get rid of this for the time being, get rid of all this. Now we need somewhere to get JS hint from, which is the Gradle repository. We add a new task of type JS hint. We want to analyze all the files in here. We run Gradle JS hint. And we've got a bunch of problems with our source. Notice the error messages, compare them to the ones we got previously in running JS hint. When it's a bit messed up and it was pretty noisy. These error messages are coming from Java code that is driving JS hint via Rhino. So when JS hint is being run, it returns something like a dictionary back of all the problems. then the Java code is looking at that and then turning that into this kind of nicer output. It's only possible by getting access to the JavaScript data structures to provide some info about. And we can also use that to spit out some more interesting information as well. So even though this is a JSON file, this is actually coming from the Java code. JS hint doesn't provide us anything like this. So really, really deep integration with JavaScript code. You can really do anything. And that's out of the box, you get that. Just kind of works like all other Gradle tasks, like you would expect Gradle code to work. So integrating with Rhino at such a deep level opens up a lot of possibilities. Okay, MJS, which you've already spoken about a little bit. Portable, headless browser environment, 100% JVM. And there is also some infrastructure for using MJS to evaluate pages. And really, we get to talk about unit testing here. So a browser evaluate task, it means that this is the content we're going to serve, everything in that directory. I want the browser to go to this file in this directory and evaluate the page and write it out to here. Right. We're doing what we did before with the Jasmine unit test example, where we ran MJS and Rhino, automatically ran some unit tests. This is some extra Gradle tooling that just makes that more convenient. And there's an abstraction here around how does the page actually get evaluated. There's a key interface in here saying that go to this page, evaluate it, and write it out. What that means is that we can actually do it with different evaluators. If we're running on CI, we want to evaluate this page with NJS. If we're running on the desktop, let's use Firefox so the developer can actually look at it. It's just the same thing at the end of the day. Send the browser there, tell it to evaluate it, what did it get? Didn't want to do that. Nope. All right. First thing I need to do, just to kind of show off the flexibility, my actual set of tests I just want to actually get from Jasmine itself. So I'm going to download Jasmine from its website using a task I wrote to just download something from a URL. So download Jasmine. Because it has some example tests in there, that's what I want to run. I was too lazy to write my own test for this demo. So now I want to unpack it. Now I have this run Jasmine here. Just comment this guy out. It's a task of type browser evaluate. We're going to serve the content in the place where we unpack Jasmine. Spec runner is the resource that we want to evaluate. We want to write the result here. Now at the end, what we do is we copy the rest of the files over to where we evaluated it so that the images and extra JS and things are there so we can open that file. I'll show that. We also go and look and we do a poor man's check to see if the test failed or not. If the test failed, then Jasmine is going to write that to the result HTML. This line. That's how we can fail the build without failing tests. Gradle. So that actually just ran our unit tests. In here, our results. There's what Jasmine wrote out to the browser as the unit tests were running. Let's make something fail. Player spec displays the spec. Let's just make this fail easily. Say not. I think that's right. Failing Jasmine tests. So our JavaScript unit test failed. I think we'll actually get some kind of syntax error, yeah. So now Jasmine gives us different output. Yeah, so this is now a static HTML file, which was the state of the browser after the test had finished running. So we could save this off and view it on the CI server. So this is nothing different really to what we did before, where we scripted up our own solution to running JS unit tests using Rhino and MJS and Java Exec, etc. We just get a kind of nicer Gradle API. And if we're using MJS, we actually also are using the Gradle Rhino integration to get better integration there as well. But this evaluator mechanism, let's say that instead of using MJS, which is the default every time I create one of these browser evaluate tasks, I want to use Chrome to run my tests. What I've done here is just create an implementation of a browser evaluator using Selenium to automate Chrome to open this URL. So instead of using MJS in a faked out browser, I'm going to use a real one. And all I have to do there is create an implementation, use Selenium, which gives me a nice API for this, specify that the evaluator is Chrome, Gradle run Jasmine example, and we should see Chrome pop up. Or not. Didn't save the file. That's Chrome. It's pretty quick. There weren't many JavaScript tests, so it actually shut down before we actually got to see the page. If it lasted for longer, we would have seen that. But don't have a quick, easy way to do that, unfortunately, because there's no sleep in JavaScript. So simply swap that out, put in a new engine in order to evaluate that, and I can run it. So I could run that for doing cross-browser stuff if I absolutely want to. So looking forward, where are we going to from here? Well, some of the challenges in this space in automation, that there is no real equivalent of a Maven Central. Kind of hosting infrastructure is spread out. Different libraries are available in different places. Google's repository has quite a few, not everything. There's no standard descriptive format. There's no common way of talking about these dependencies in the JavaScript world, which means automation takes on a different form. Another really interesting question is, what exactly is a dependency? If I depend on jQuery UI, am I talking about the CSS or the images or the JavaScript that's part of jQuery UI? Dependencies are much more complex things. In the Java world, we're kind of spoiled because a dependency is a jar, it's a simple file, put on a class path, job done. So there's some interesting things that happen here. And if you're in this space, I encourage you to look at Require.js or some kind of runtime dependency management for JavaScript. Require.js gives you a structure, or AMD gives you a structure for writing your JavaScript code in such a way that it's modular and namespaced and maintainable over time. So I'm not going to talk too much about that, but runtime dependency management, just start with Require.js. So Require.js gives our code some structure, and I think we'll see over time the tooling starting to use this structure. It's a kind of metadata format in itself, where you have a module declaring dependencies on other modules, etc. So we can start to see tooling using this. We are starting to see that with Grunt. Bauer from the Twitter folks, is starting to become the central registry for JavaScript libraries. It's a way of pulling down JavaScript libraries, and there's a command line interface where you can say, Bauer install jQuery, contacts its servers, goes and gets it, etc. So definitely something worth looking at. And interestingly, it uses, instead of using a Maven Central type approach, it goes and fetches things from GitHub. So it's very extensible. Why bother with this stuff, dependency management in general? Well, I think we're going to see this over time, that in the early days of Java, we weren't so concerned either, as many projects only had a handful of dependencies. As your list of dependencies grows, you really need proper dependency management. And it becomes about asking questions such as, what exactly are my dependencies? That can be hard to work out in a JavaScript project where you have everything checked in. You've lost a lot of information, so it's becoming important. And we can use that information at runtime. We can actually generate things like require.js shims and all the information that we need from the build. Project conventions, as I said, there's nothing really out there. There's no equivalent of source main Java in the JavaScript world. Something that we're keeping an eye on and hoping that we can give that kind of out-of-the-box experience with Gradle going forward. Project Nashorn, very interesting. Java 8 is featuring, out of many things, a brand new JavaScript engine, completely rewritten. This will effectively replace Rhino. And speed is one of the primary design goals. Rhino is great, it's portable, it works, but it's not the fastest JavaScript engine around. It's been eclipsed by things like V8. So Nashorn is a competitor, trying to be a competitor to V8 for a very fast, modern JavaScript runtime. And it's going to be embedded in Java 8. So that means we will have, on the JVM, a very, very good, high-quality Java-based runtime. So we can. I think Node.js on the JVM won't be far behind this. A very good implementation of it. And also that means that the work we've been doing with Gradle with Rhino, we can put in Nashorn underneath instead. So I'm really excited about that. I think it's going to change things in the JavaScript space dramatically. So, wrapping up, Gradle has a lot of inbuilt mechanisms that make it easy to do your own types of JavaScript automation. We saw the file API, exec, Java exec, etc. It's really not that hard to kind of roll your own solution to do JavaScript automation. And don't forget about the Ant integration. The new core stuff that is there that we hopefully will be making public and documented and all that stuff quite soon. Very deep Rhino integration, or more generally, deep integration with the JavaScript runtime. Some interesting abstractions around browsers and DOM evaluation environments. And out of the box, you get a 100% portable MJS environment for running JavaScript unit tests. Like a lot of people here at this conference, the first thing they're going to have to support is probably running JavaScript unit tests on the CI server. So to do so in such a portable way that doesn't require browser installs, etc., this is not a bad option.
And you're saying that's going to be in the core?
It is, everything I've shown today is in the core right now. You can use it.
Well,
it's just there's a significant lack of documentation.
But I have to do dependency management out to get stuff.
You have to manage.
It's not actually going to be in the Gradle core. Like the NJS core itself.
The MJS plugin does get it from Gradle servers automatically.
Yeah, well,
we can change.
I'm a lockdown environment.
You can change it quite easily. Put MJS in your repository, change the configuration. Yep. So the initial focus is about infrastructure, not necessarily about a Java plugin equivalent in the JS world. Trying to enable that and make tooling possible, and over time, looking at dependency management, potentially integrating with Bower, those other kinds of tools. So, not too much out of the box right now, but you can build your own. The flexibility of Gradle makes it compelling to sit on top of other front-end tooling. We saw Compass, we saw Grunt Js. You often need a controller on top of all that stuff to bring everything together. And Gradle's a great fit for that. Simple to wrap specialized tools, and we view JavaScript as a very important platform going forward. So we're looking at it a lot, investing in it, and hope to be a really high-quality, first-class environment for automating JavaScript, integrating JavaScript tooling with the rest of the enterprise. Let's put it that way. And thank you very much. Any questions? Yeah.
So you kind of focused your talk and a lot of the infrastructure on JavaScript, but you mentioned there's also, there's Sass, which eventually gets compiled into JavaScript. There's
It gets compiled into CSS.
Yeah,
so
into CSS.
Coffeescript, yeah.
Yeah, there's that. There's different languages that actually do like Coffee, I guess, like for example, that compiles into JavaScript, and images, CSS, straight CSS files, etc. So typical, we call them static content, for lack of a better term. So have you guys thought about elevating the concept to be static content instead of JavaScript specific, and having both producer and consumer models for such artifacts?
It's largely there. I mean, Gradle, in that case, you're really just talking about file system and file system processing. And Gradle is already pretty capable at that, but things like document sets, like the equivalent of a source set, but talking about a specific set of documents and modeling its processing pipeline. Those kinds of things are missing. And yes, that is something we talk about quite a lot, and it's something we want to model, because that's the reality of modern applications, is that a lot of this stuff was typically done at runtime previously, but now is a trend towards deploying something light, something static, so it's a lot of build time automation is needed. So no, there's not anything there that I haven't shown, but yes, it is something we are aware of and considering.
Well, I mean, the other thing is deployment model, when you think about CDNs, is very different than, you might not be deploying this with your application, you might be deploying it separately.
Sure.
CDN, etc. So, I mean, there's lots of areas of improvements and opportunities to actually glean in this space for Gradle.
Sure. Yeah, no doubt. Maybe I gave you the wrong impression. We're not just trying to ride along with things like Grunt Js and Compass, etc. But right tool for the right thing. Those tools are better situated at the moment to do JavaScript processing, watching, etc. Especially for people who are more focused on the JavaScript environment. They can write their build automation in JavaScript, ignore the backend stuff, right? And then you can glue it all together at a higher layer. So there's that aspect of it, but we're not just content with doing that. Yes, like we are looking to innovate in this field, I guess. But yeah, I don't have anything concrete to give you, but yeah, it is something we are aware of, and that's what we're saying. This is JavaScript as a platform is very important, but this whole area of easing automation of front-end development is probably a better way to state it.
So by the way, we built most of this, or all of this, all the stuff I'm talking about, we built in Gradle.
Right. I'd love to talk more about it. Yeah. So yeah, please catch me outside. Yeah. Yes.
So one of the problems that we're running into, maybe we're approaching it wrong or whatever, but like when the developers are working on things, we put it out to like a development or QA kind of server. We want to have just here's all the basic code or whatever. Like I think we're using less CSS. But then when we deploy it out to production, we want to compile that all down, compress it, get rid of all the code portion of it. What's the right way of doing that? So, because it's almost like two separate build paths.
Right. So there's no kind of.
Can I ask a question on that? So are you saying that your test environment has basically a different set of code than your production environment?
Well, for like CSS, right?
For anything. I'm saying that's bad. Because now your production environment is not the same as your test environment.
But when it comes time to debugging stuff, you don't want a compressed set of code to be able to look at and debug, right? You want to be able to look at the actual code and stuff.
You debug locally, don't you?
Right, but then now we're talking about the developers separating themselves from using Gradle to build this stuff.
Sure.
Right?
So there's no easy answer here, because it's very custom to how your particular processing pipeline works. There's a general concept. At the start, we looked at we had that all JS, and we plussed some JavaScript together with some Coffeescript, and we said that downstream processing wasn't affected by upstream. We could, for whatever environment we're building, change that definition of all JS, right? So instead of it pulling in the compressed JS, just use the raw JS, that kind of thing. So you do need to then add this logic to your build, that okay, what I'm building for this additional flavor, etc., then this is how I do things. But there's no kind of silver bullet for that. It's just you have the kind of raw tools you need to configure the build appropriately.
We're using like the all JS kind of methodology where you change it depending on.
Yeah, I think the key there is to not to create point-to-point connections between your processing instructions, right? So use these intermediary things that can have different definitions or different configurations in different environments. So therefore, you don't have to have parallel configuration for dev, test, etc. for the whole pipeline. Just the bits that are different, you can configure them differently. Right? All right, thank you very much. Yes.